Hey guys, today we're going to talk about the next section 3.4. And the good news is it's very, very, very similar to what we did previously with in section 3.3, which was increasing, decreasing, right? We took the derivative, we, we found the critical values, we then made a number line, and we figured out and plugged into we did interval testing, and wherever it was positive, the derivative, that's where the original was increasing. Wherever it was negative, it was decreasing. All right, so all that stuff we're still going to be doing, but we're just going to take it one more step further, and we're going to do the second derivative and basically do the same thing. We'll find critical values in the second derivative, and what the second derivative tells us about the original is concavity. All right, concave up and concave down, meaning our curve or our function, something's concave up, it's the two parts of the parabola facing up. So anything that looks like that or like that is concave up, concave down, looks like that. All right, we don't have to worry too much about that yet. We'll get to that when we start graphing. All right, but real simple. If the second derivative, wherever the second derivative is greater than 0, so where it's positive, the function is concave up. Wherever the second derivative is negative, the function is concave down. All right. Now, with the first derivative, if something changed from increasing to decreasing, right? If it was increasing and decreasing, it had a max, so wherever it changed signs. Well, we're not going to have the second derivative with concavity tells us points of inflection, right? Points of inflection are where the curve changes concavity. So when we do these examples, you'll see anytime on the number line with second derivative, wherever it changes signs, right? So that would mean like something was concave down and then switch to concave up, right? Something like that, like you can S curve or something like that. All right. So what we're going to find now is not just increasing, decreasing. You can see here, if you remember the examples we did in class, I like crossed out the second part because we didn't have to do it. Well, now we do. All right. So for these examples, we now have everything. We're still going to do increasing, decreasing, relative max, relative min, but now we have the second derivative to go with us. All right. Now, so for this example, first thing we're going to do is just what we did before. All right. So I'm going to find my derivative, all right, which is 4x cubed minus 12x squared. I'm going to set it equal to 0 to find any critical values. I could take a 4x squared out, and that leaves me with what? X minus 3. So my critical values that I will put on my number line are 0 and 3. All right, 0 and 3. All right, so now I'm going to take those and plug them in. So if I plug a negative number, all right, well, first of all, anything squared, whether it's negative or positive, is when you square, it's going to stay positive. So that's going to be positive. Then if I had negative 1 minus 3, that is a negative. A positive times a negative is a negative. If I plugged in 1, that's still going to be positive. 1 minus 3 is still a negative. Positive times a negative, still a negative, right? So now we have an example where it's not always alternating. And then if I have greater than 3, right, that's going to be a positive. And then say like 4 minus 3 would be positive. A positive times a positive is a positive. So I'm increasing from, 3 to infinity. I am decreasing from negative infinity to 3. All right. So from negative infinity to 3. It's not changing, so we don't like write negative infinity to 0, union 0 to 3. You write it like this. All right, so maxes and mins. So we only check where they change, right? Negative, so it's at 3. It goes from being negative to positive, which means it goes decreasing to increasing, which means we have a min. So there is no max. There is a min at 3. We go to my original and plug that in. 3 to the 4th is 81. 3 cubed is 27, and 27 times 4 is 108. So 81 minus 108, which is 19, and 8, which is 27. So negative 27. All right, that's where we have a relative min. All right, so that's what we've done before. All right, so now what we need to do, this was my derivative. All right, this is the first derivative. I need to now find the second derivative. All right, going to find the second derivative. So let me take the derivative of the derivative. So the derivative of 4x cubed is going to be 12x squared minus 24x. Set it equal to 0. Take out a 12x. I am left with x minus 2. So my critical values for the second derivative, and I'm going to draw a number line, are going to be 0 and 2. All right, 0 and 2. And now we're going to do the same thing that we did with the first derivative. Now we're plugging into the second derivative. So if I plug in a negative number, that is a negative. Negative 1 minus 2 is still negative, but a negative times a negative is a positive. If I plug in positive 1, 12 times positive 1 is a positive. That stays a negative in there, but a positive times a negative is a negative. Anything bigger than 2, like 3, then a positive times a positive, which is a positive. So now what this means, wherever it's positive, it's concave up. The original. So from negative infinity to 0, union to infinity, concave down, it is from 0 to 2. All right, now points of inflection is wherever it changes. So it goes from positive to negative. So we have a point of inflection at 0 and a point of inflection at 2. So I got to plug in 0 and I got to plug in 2. And where am I plugging into? The original. If I plug 0 into the original, I get 0. If I plug in 2, I get, what is that? 16 minus 32, because 2 cubes 8, 8 times 4, 32, which is negative 16. All right, so now we now know where the original function is increasing, we know where it's decreasing, we know where it's concave up, concave down, and all of its max, mins, and points of inflection. All right, so the second derivative just tells us about concavity, but we do it the same way we did it with the first derivative. All right. So let's scroll down here to this, our second and last example. All right. Now, I think I told you this the other day. When you have something with a fraction like this, I will, on a quiz, give you what the derivatives are because they get complicated, especially when we throw the second derivative into it. So I would give you what the derivatives were equal to on a quiz because I'm more concerned with applying it and knowing what it means than actually finding it. All right, so the first derivative in this one is negative 10x over x squared minus 4, that whole thing squared. All right, which means our critical values are going to be, we set the top equal to 0, which is 0. We set the bottom equal to 0, x squared minus 4, that's plus or minus 2. So I have 3 critical values. All right, now I mentioned this at the end of class, I guess it was Friday. With a fraction, when you start off with a fraction, you have to be careful. What is happening in the original function at 2 and negative 2? There's a vertical asymptote because it makes the denominator equal to 0, which means there's a vertical asymptote there, meaning we can't have any points on those asymptote, those lines. So we'll deal with that in a second when we potentially can have max or mins. Right? So with fractions, if you have a critical value that is the same that makes the bottom equal to 0, you have to know that that's an asymptote. All right, so go ahead and plug those in and see if you can figure out where it's increasing, decreasing, what the relative max and the relative min are. Okay, so 4 should have been, let's see, if you plug in anything less than negative 2, so I plug in, so the nice thing is here, and this is where, no matter what I plug in, the bottom is always positive, right? Because I'm squaring something. So I only have to worry about the top. So when I plug in a negative number, negative times a negative is a positive, positive or positive, positive. Negative 1, also positive. If it's positive, it ends up being negative. So it should be positive, positive, negative, negative. All right. All right, so that means we're increasing. Now, normally it would be from negative infinity to 0, but because of the asymptote, all right, we have to write a union sign only because there's an asymptote there. So it's negative infinity to -2 union -2 to 0. And the same thing with decreasing. It's 0 to 2 union 2 to infinity. Right? You have to put the union there, whereas you did not have to put it in this one because that wasn't an asymptote. So the only place it changes is at 0. 0 is not an asymptote, so you're okay. So we goes from positive to negative, which means we have a max, which means there is no min, and you must put like a slash through it or put none, because if you just leave it blank, I think that you don't know what the answer is. All right, so relative max is at 0. Plug in 0. What do I get? 0 plus 1 is 1. 0 minus 4 is -4. So I get -1/4. That is my relative max. All right. Now for the second derivative. Now this one, be very happy I'm giving to you. This was a doozy. All right. So this comes out to be -10 times -3x squared minus 4 all over x squared minus 4 cubed. All right. All right. So we have to set it equal to 0, right? The top and bottom. Now, when I set the top equal to 0, don't worry about the -10. You only worry about what's inside that parentheses. But when I set this equal to 0, when I bring this over, I get a +4, and then I would divide by a -3 and have to take the square root. You can't take the square root of a negative number. You can, it's imaginary, but so there is no real critical values from the top. The only thing from the bottom I get is the same, which I had plus or minus 2. So -2, +2, but remember, they are asymptotes. I like to draw in, so when I'm writing my answers, I don't forget. All right, so go ahead and try to plug in less than -2, interval test it here, and so you can figure out where it's concave up and concave down. All right, so concave up, when I plugged in a negative number, it's like -3. So -3 squared is going to give me a positive. Positive times a negative is negative. Subtract, I'm going to get a negative there, but a negative times a negative is a positive. Then -3 gives me -3 9. 9 minus 4 is 5. 5 cubed is still positive. Positive or positive, I get a positive. If I plug in 0, 0 minus 4 is a negative. A negative times a negative is still a positive, right? And then, which is always going to be the case because I'm always going to get a positive number times a negative, subtracting a negative times negative. So the top's always positive no matter what. If I put 0 in there, on the bottom, 0 minus 4 is -4 cubed, which is negative. And if I plug in 3, it ends up being a positive again. So it is concave up from -infinity to -2, union 2 to infinity, concave down from -2 to 2. Now, where does it change points of inflection? What do you think the points of inflection are? Well, it changes here and here, but they're asymptotes. So guess what? There is none. All right. There is no points of inflection. All right. So the only thing that's different for today is that we now talked about the second derivative test. So we did exactly what we did. And don't really worry about actually the second derivative test. Just the second derivative tells us about concavity. Okay. And just like we did with the first derivative increasing, now we do the second derivative. Wherever it's positive, it's concave up, and negative is concave down. Wherever it changes signs from plus to minus, minus to plus, that's a point of inflection. We don't have to worry about if it goes positive, negative, or negative to positive. Anytime where it changes, that is considered a point of inflection. All right. All right. So probably just like assign 1 or 2 examples for you guys to do. And then, I'll be able to answer any questions that you guys have. If you have, reach out. Anything you don't fully understand, don't worry about it too much. We'll just cover it in class tomorrow when hopefully I see you guys. All right. Hope you guys stay safe, and I'll be talking to you soon.